All right, first thing is about inverses. I'm going to show you how you make an inverse. You take the line y equals x, and then when you graph something, let's say I were to graph that. To get the inverse of it, I will flip it across that line. So for instance, if this is the point 0, 1, then the point 1, 0, which is flipping the x and the y around, must be on this graph. Another example, let's say at 3, 6, let's say that's 3, 6. Then what other point has to be on my new creation? 6, 3. So if I go over 6 and up 3, that's like about there. And this point, I'm going to use the method of just going straight across the line. That point right there, if I go straight across the line, is going to be right there. All right? One more thing. How about this? This is like negative 4, 2. That's about right there. Negative 4, 2. So then I need to go where? 2, negative 4. Like, let's see, about there-ish. Now watch me connect the dots. Those are hard to do in just freehand. It's way easier if you, I don't know, can you see that these points are right across the line from each other? Yes, looks like a fishy now. Blub, blub, blub. Fish go blub. All right. Any questions? All right, then let's see if you can do it yourself. Here's a dotted line like this, make this, and then I'm going to give you a graph, and I want you to see if you can make its inverse. I'll give you some hints. This is at 0, 6. This is at negative 3, 0. And this is at negative 5, negative 3. Once you have 3 points like that, this becomes an easy problem. Go ahead, graph it. Write down on your paper or your iPad. If you do it right, it will. All right. So I'm going to go to 6, 0, put a dot. Also notice, see how these line up? You get that? Go straight through the line. Another spot. Negative 3, 0 becomes 0, negative 3. About there. Not perfect, but close. And the last one, negative 5, 3 becomes negative 3, negative 5. It's down, let's see, so that's negative 3. That's negative 5 is like about there-ish. All right, now I got to connect the dots. Certainly not perfect, but as a reflection. And these reflections are harder to see than like the kind where it was like, ooh, waves this way, and then you can just do the exact wave on the other side. They're harder because they're at this angle. All right, I think you're going to like this other part better because we can create functions and their inverses. Say I took this. Would you agree that that is a simple function? Y is the same as f of x, right? So I could start with f of x there if I wanted to. This is a function. Then any function that is out there can have an inverse. So I can create this guy's inverse. All right. I'll give you a three-step process that you want to write down. Step 1. Seriously, you want to write this down. Step 1, step 2, step 3. Step 1 is always replace f of x with a y. It's as simple as that. You put a y in for it, because f of x and y are pretty much the same thing. So I'll do that. Y equals 3x plus 5. I just replaced f of x with the y. That's it. Mr. J, can you put that phone away, please? This is the second step. Replace, switch x and y around. Switch them around. As in, wherever y is, put x. Wherever x is, put y. So instead of y equals 3x plus 5, it's x equals 3y plus 5. All I did is flip-flop these. Remember how in this problem we were going like 2 comma 6 becomes 6 comma 2? X and y get switched. All right. That's step 2. Last step, step 3. Solve for y. You know how we usually have it solved for y? Y equals blah, blah, blah. Well, now it's solved for x right now, so we got to solve it for y. So I'm going to take this, x equals 3y plus 5, and then subtract 5. X minus 5 equals 3y. And then how do I get this finalized? I just have to get the y alone. I'd keep saying that to yourself. Just need to get y alone. Divide by 3, divide by 3, divide by 3. Y is alone now. I'm going to rewrite it to make it cleaner. Y equals, and x over 3 is the same as 1/3 x. And then minus 5/3, minus 5/3. It's okay if there's a fraction in it. If you were to graph this on a graphing calculator, you would find it is the perfect reflection across that dotted line of the original that we had right here. And let's look at some things that are different about it. This one had a slope of 3. This one has a slope of 1/3. This one added something. This one's subtracting something. All right. Let me give you one to try. Let's say you had f of x equals 3x minus 8. Tell me what the inverse of that is. Use the three-step process. So you get y equals 3x minus 8. Now, flip-flop x and y. X equals 3y minus 8. Now, solve for y. And this gets confusing, so keep saying to yourself, okay, is y alone yet? No, I got to add 8. So I'm going to x plus 8 equals 3y. Is y alone yet? No. I have to divide by 3. And now is y alone? Yes, it is. Y equals, notice this is x over 3, 1/3 x plus 8/3. If you graphed this and you graphed this, they would be a perfect reflection of each other over the line y equals x. Okay. One last one. This one I should be able to just release you and say, I know you can solve this. 1/3 x plus 2. Find its inverse, please. I will pause while you work on it. Okay, you should have said y equals 1/3 x plus 2. Then you should have flip-flopped x and y. X equals 1/3 y plus 2. Now you subtract 2 from both sides. X minus 2 equals 1/3 y. Now I got to get the y alone. I got to multiply both sides by what? By 3. That's how you get rid of this 1/3. You're going to times by 3. Here and here and here. All the parts of it. Some people would have just picked one of those to multiply by 3. That doesn't make any sense. You're going to just randomly choose a number to multiply by 3. All right, so anyway, I get y equals 3x plus or minus 3 times 2 is 6. And notice the original one had a slope of 1/3. This one has a slope of 3. The original one was adding something. This one's subtracting something. So they're quite different. But when you graph them, they would make a perfect reflection over the line y equals x. How many of you had that one right? Raise your hand if you did. Okay, good. You've learned how to find a inverse, but they can get trickier just because the algebra can get trickier. Okay, you're still going to solve that same 3-step process. Make the y, make it y, then flip the x and the y. That's always the easy part. This last part, the solving part, sometimes is a pain in the butt. So I'm going to do one of your homework problems with you that's like that. But there's one more concept that you have to know. They're going to ask if a function is what's called one-to-one. If you have a one-to-one function, then you guys already know about the vertical line test, don't you? The vertical line test is the one where if this thing passes the vertical line test, it's because I can draw a vertical line and that this, it'll only touch once as I go across this function. That means one input would have only one output. Okay, so that's the vertical line test. Take a wild guess what the other line test is called. You got it. The horizontal line test. And the horizontal line test is just like the vertical line test, except sometimes it just surprises you. Do you get how this one does not pass the horizontal line test? Because for one output, there's several inputs. Another way to say it is it touches more than once. Right in here, it touches like 3 times. Or infinitely many times, anyway. It passes here, 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 and then all of a sudden, it touches twice. It's out. Okay, so this one is not a one-to-one function. I want you to just look at some pictures quick and tell me, is this function, first of all, is it a function? Is it a function? Yeah, because it passes the what? Vertical line test. Is it a one-to-one function? No, because it would definitely not pass the vertical or the horizontal line test. It's 3 spots there. Okay, so would anything pass that? Yeah, some things do. Nice simple function. Is that a function? Does it pass both vertical and horizontal? Then therefore it's a what kind of function? One-to-one function. Now, what does it mean if you are a one-to-one function? It means not only that you would pass both those tests, it means that your inverse will also be a function. See, some things are a function in the first place, but their inverse can't be. Give you an example of one. There. Is that a function? That kind of J-looking thing? That's a function, passes the vertical line test, right? Now, if I do the flip, these are hard to do. That point and that point go together. Say that point goes together with that point. Say this and this would go together, and that would go together. And then this, let's say here. It's going to be like, so let's say that's -3, 3. So it's going to be 3, -3. About there. And then this one's at like, there. Do you get how that's a reflection? May not be perfect, but do you get the idea of the reflection thing? So those are inverses of each other, but this one is not a function. Why not? It doesn't pass the vertical line test. Okay. And how would I have known that? By looking at this guy. He wouldn't have passed the horizontal line test. So if it passes both those tests, then its inverse will also be able to be a function. It's sort of like a really special function. If you pass the vertical and the horizontal line test, then your inverse will also be a function. All right, so quick, is this a one-to-one function or not? No, because it doesn't pass both tests, and therefore its inverse would not be a function. Okay? This, because it doesn't pass the horizontal line test, therefore it's not in a one-to-one function. Therefore its function would not be, or its inverse would not be a function. All right, that's what one-to-one is. Just check the vertical and horizontal line tests. If it passes both, it's one-to-one. All right, that's all the new stuff. Now I'm going to actually do some of the homework with you. Here it is. It's the first few problems are super easy, so it's not as scary as you might think. There's just a couple ones where the algebra gets intense. Yes, you may. Go. I think there's 6 there. Okay, for number 1. Question number 1, it's sort of, the graph that you have sort of looks like that. Okay, is it a function? Not a function in the first place, so it's definitely out. So part A is it a function? And it's everything's a relation. But is this a function? No. And B, does this relation have an inverse that is a function? How do we test that again? Not the vertical line test, the horizontal line test. Would this thing pass the horizontal line test? Yes. So its inverse would be a function. Yes, because it passes the horizontal line test. Okay. So number 2, is that a function? Number 2 is a function because it passes the vertical line test. Is it going to have an inverse that is a function? No. Number 3, is that a function? Yes. Does it pass the horizontal line test? Yeah, so it's a special one-to-one function, so its inverse will be a function. Okay, I think you got those handled. I think that there's enough problems on here that it'll be a little intimidating, so I would like you to skip a few with me. Everybody get into crossing out mode. We're going to cross off problem 6, problem 8, flip to the next page, problem 10, 12, and 14. And then it becomes a reasonable sized homework assignment that won't kill you. Oh, and number 18, sorry. Number 18, you may skip. Cross off 18, yes, all the parts. All those are word problems that have a function in it, and then if you do the inverse of the function, you can answer the question. So it's not that scary. You just have to do an inverse to solve the problem. Okay, but now let's go back to where we were, except you can handle 1, 2, 3, and 4. Let's do number 5. Please try number 5 right now and see if you can find that inverse without me, because I don't think you should need me to do that 3-step process. Just in case that isn't clear, the directions say find f-1 of x. Take a wild guess what f-1 means. Inverse. That's the whole point of today. That's the funky special name for an inverse. So you're trying to find the inverse on number 5, 3x minus 6. First thing you do is set it equal to y instead of f of x. There's my first step. Second step, reverse them. Third step, solve them. I'll tell you in a second what it is. You tell me if you get the same thing as I did. Okay, I got to go kind of quick here because I know some of you are going on to the next problem, and that's the one that's going to blow your mind. Okay, so then I'm going to divide by 3, divide by 3, divide by 3, and then x is, oh wait, I didn't switch my x and my y, duh. Sorry. There we go. Okay. So then final answer, y equals 1/3 x plus 6 over 3, when 6 over 3 is actually equal to 2. Raise your hand if you had 1/3 x plus 2. Okay, good. You can do a simple inverse. Now number 7. Does it ask? Oh, it does ask for that. Okay. All right. I did not notice that, and I didn't assign it in, well, no, that's in the directions, so it would be assigned. All right, let me tell you how to do it. Domain and range. What you do is you go to the original problem's domain and range, the domain and range of the original problem, this one right here. Do you know what it would look like? It's just a line. It's just a line that touches at -6 and has a slope of 3, so it kind of looks like that. Okay, what's its domain? Negative infinity, positive infinity. And I'll tell you why I'm doing that in just a second. And then the range of that thing, how low would it go? Negative infinity to positive infinity. Remember how x's and y's always got reversed from when you do inverses? So then this is the inverse of that function. So its domain and range get reversed. In this case, it's kind of irrelevant because they're both negative infinity and positive infinity. But let's say this had been like 2 to 5 or something. Then the domain of this one becomes the range of this one. So whatever the domain is here, it becomes the range. So I'd switch around and say that 2 comma 5 is the range. They get switched. Right? But in this case, since they're both negative infinity to positive infinity, then the domain and range, even if I reverse them, is the exact same thing. Negative infinity to positive infinity, and negative infinity to positive infinity. Again, technically what happened is the domain became the range, and the range became the domain. Just like x and y got switched, domain and range got switched. Because domain's about x's. And range is about y's. So you switch them. All right. Now let's get to number 7 that I know is going to mess with your head. Start by making it a y equals 2x minus 3 over x plus 1. Then you switch x's and y's. That's easy. X equals 2y minus 3 over y plus 1. I just switched the x's and the y's. I could teach a second grader to do that. Now here's the hard part. Got to get y alone. Think back to some things I've taught you in the past. Whenever you have a fraction, what do I teach you to get rid of it? Multiply by what? The opposite? What are you talking about? Multiply by what? No. Let's say I had 1/3 x plus 7 equals 12. How would I get rid of this 3 here? Multiply everything by 3. Everything would get multiplied by 3. Do you remember doing this on that basic sheet? That's why I was giving that basic sheet to you, to remind you about how to get rid of denominators. So then this 3 cancels, and now there's no more denominators in my problem. Back to this. How do I get rid of this denominator? Well, I want to get rid of the y plus 1, so I multiply everything by y plus 1. So this gets multiplied by y plus 1. Technically, it's over 1. And this gets multiplied by y plus 1. And these guys cancel. Look. No more fraction. Now I'm going to multiply this out. X or y times x plus 1 times x. 2y minus 3. Now it's starting to get messy and it starts to get confusing, and you start asking, what am I even doing here? You're not trying to get x alone. We already had x alone. If I wanted x alone, I would have stopped right here. I don't want x alone, I want y alone. So you're trying to solve for y. So the next step in solving algebra, this is why we did all this practice at the beginning of the year on algebra, to see who could hang with it and who was going to die. Because at this point, if you can't handle basic algebra, you have no hope of solving this, and you have no hope of getting it right on the test. All right, so stay with me. If I'm trying to get this y alone and this y alone, I got to put those y's together somehow. So at least they got to get on the same side of the equation as each other. So do you get how I can bring this 2y over to the other side of the equation? Do you get that? I can subtract 2y, and that gets it over to this side. So now I'm going to have, I'll rewrite this with a different color, negative, actually I'm going to say yx minus 2y. I'm just putting the 2y in the middle because it's going to be handier. You get what just happened there? This 2y used to be on the right side, and now it's over here on the left side. You get that? Yes?
Why wouldn't you just divide by y on both sides?
It would not fix the problem. As soon as I divided by y right here, I would have a y underneath that x instead of having a y right there. So it would not have worked. I don't want to go into complicating things more, but that would not have worked. You can talk to me later about it if you want to, but you would not have gotten y alone. All right, so now I have subtracted that 2y, got it over to the other side. Now I need to get y alone. This x over here need to be with the y's? No, I'd rather have him over to the other side. Okay, so here's my next step. Yx minus 2y equals, the x is going to the other side, negative 3 minus x. Basic algebra, just moving that x to the other side. Now, you might remember this, you might not. At the beginning of the year, we gave you problems just like this, where there was a y in both of them, and there was a secret way to get it down to only one y. Do you remember what it was? It's been a month and a half now. How do you get the y to be down to just one y? No, nothing about 0. What? Y in front. That's called factoring out the y, and you put a what? You got it. Remember this now? There's a y in both of them. You factor it out to the front. Equals negative 3x minus x. No, minus 3, sorry. Minus negative 3 minus x. There. What just happened there? I had y's in both parts. Don't desert me now. You got to stay with me. This is complicated. Okay, so those y's, there used to be 2 of them, now there's only 1 of them. Down to 1 y. That's good because I'm almost got y alone. Keep saying that to yourself. I'm trying to get the y alone. How do I get that times x minus 2 off of there? Divide by x minus 2. Divide by x minus 2. This cancels this. Y's alone. Congratulations. You've got an inverse now. Negative 3 minus x over x minus 2. And don't you dare try to cancel those x's. That would only work if this was a big times problem, but these are subtracts in there. So you cannot cancel those x's. All right, now let's look at our final result. This thing we have created. It has negative 3 minus x on the top and an x minus 2 on the bottom. Well, it doesn't even bear much resemblance to the original one. But if you graph this, and you graph that, they would be a perfect reflection over that line y equals x. All right, those are difficult, and those are something you have to know. I am going to actually change this up. I told you to skip number 8. You need to do number 8, and I'll take a different one off for you instead. Do number 8. Erase it back out so you can see it. Because you have to practice this or you won't be able to get it right when we test you. Okay, and instead I'll take out a different one. Let's take off, I don't think a lot of you would know how to do number 13, I agree. We'll take off 13. Okay, so try one, like number 8. That's the kind that's going to trip you up. It's doable. It's got an extra complicated little step in there that makes it hard. Yes, the domain and range. Okay, let's go back to the original domain and range. We find that domain and range, and then we just flip them. So the domain and range on this guy, domain is, well, how do I do domain? Domain is what would make it crash, basically. Is there anything that would make this crash? Yes, there is. What would crash it? Negative 1. I'm going to say all real numbers except x cannot be negative 1. That's one way to say that. If you'd rather, I could make a number line. Go like this. Say negative 1. Can't be negative 1. If you'd rather, I can write that with parentheses and brackets and stuff. As long as you get, it can't be negative 1. All right, how about the range? The range on this is a y equals thing. Do you remember who tells us the y equals things? Bob. Bob tells you the y. Is this bigger on bottom, bigger on top, or same on both? Same on both. Do you remember the deal with the same on both is that they're SOBs to figure out because they're a ratio. Good. Y equals 2. So then that means 2 is the thing that won't work in the range. Lot to remember. Now, that's the domain and range of the original one. What they wanted is the domain and range of the inverse. So we just reverse them. So for my inverse, the domain becomes whatever the range was. Can't be 2. The range becomes whatever the domain was. Can't be -1. Now, I know you're going to go home like your head hurting. These are challenging. Yes, you're in a hard math class, but you can do this. You can. You might have a little bit of trouble with the algebra or something. Come in the morning, ask me for help if you really, really want to know how to do this. Otherwise, check the answers. The answers are getting posted. I know last night's didn't. This is the first night it hasn't been posted in a long time. So we should have the answers up again tonight. But don't expect them until, like, it's going to take a while. Teacher actually get them done. I'm guessing dinner time. So maybe check after dinner. The answers should be done. Should be up. Okay. And don't quit. We do have tomorrow to teach you this exact same thing. Review of this tomorrow. Okay? We'll be teaching you the same thing tomorrow to make sure if you didn't get it this time, maybe you got some of it. And then tomorrow you'll be like, oh, I see. I get it. Okay? And then we review on Monday, and then the test will be Tuesday. All right. That's all I got for the video for today.